This is Geometry, Unit 2, Lesson 2 on angles. An angle, by definition, is the union of two rays with a common endpoint. I have a picture over here of an angle. The two sides of the angles are called the rays. This is a ray, and this is a ray. And they meet at point A, right here, which is the common endpoint. This common endpoint is called the vertex. So you can see the angle is made by the two rays with a common endpoint, and what you're looking at is how much this angle opens. That is what the angle is. Now, how do we name an angle? The angles are named basically by three ways. There's three. The most common one is the first one. We can name it by three letters, but the middle letter is the vertex. That's very important because you have to be consistent. The name of this angle, using the three letters and the A is the vertex, would be angle BAC, or you can say angle CAB. Either one is correct, but notice on both of these, A is in the middle because that is the vertex. Now, you can also, in some cases, name an angle by a single letter at the vertex only if there's no chance of confusion. So in this angle here, I can also call this angle A because that's the vertex. And there's no other angle called angle A here. Now, you also see the third way, by a number or lowercase letter placed inside the angle near the vertex. That's usually used when you're calculating something or naming something. So we could also call this angle 1 based on our diagram because it has the 1 on the inside of the angle. So that's the three ways that you can name an angle. Now, using the diagram, which angle cannot be named by a single letter at the vertex and why? All right, let's look at our letters A, B, C, and D. A is a vertex, B is a vertex, C is a vertex, D is a vertex. Now, if I look at angle A, there is only one angle A there. That's the only way we can do that. And same thing with angle B. But let's look at angle C. If I look at angle C as my vertex, angle C, right here, I don't know if I'm talking about this angle for angle C, or angle 6 or angle 5 also has a vertex at C. So angle C could be angle ACB, it could be angle 6 or angle 5. We're not sure, so we can't say for sure what angle is angle C without knowing some more information. So if you have any ambiguity there, you're not sure which one it is, use the three letters. This one we would definitely have to say would be angle ACB so that we know specifically which one we're talking about if we're talking about angle C. So don't use the vertex one unless you know for sure that's the only one that there is. The measure of an angle. The measure of an angle is how much the angle opens. So when you see the measure of an angle, I have angle A here. Notice that inside the angle is 50 degrees. The notation for this is we are measuring how far it opens from here to here. It is not the sides of the angle. The notation is the measure of the angle and whatever the name of the angle is. So for this particular one, we would say the measure of angle A is equal to 50 degrees. The name of this angle is angle A because A is its vertex, and it's 50 degrees because that's how much it opens. Now, it also says here the measure of an angle is a measure of rotation or turning. It has nothing to do with the length of the sides. This side is not 50, this side is not 50. This says this angle opens 50 degrees. You are rotating from here to here 50 degrees. So be very careful about that. So all the little m in front means just measure of the angle equals 50 degrees. Now let's look at some types of angles. An acute angle. Yes, it's adorable. An acute angle is an angle that measures less than 90 degrees. So if you were to draw that, you would draw it less than an L. So if I was drawing an angle like this, it would be less than an L. It opens less than 90 degrees. So this would be an example of an acute angle. For example, say this could be 40 degrees. This angle could be 40 degrees. Okay. The next kind of angle is a right angle. It's an angle that measures exactly 90 degrees. So that's the one that looks like an L. It's a perfect L. And usually when you see a right angle, there will be a little box in the corner to indicate that this is a right angle. The little box means it's a nice square corner. So that is a right angle. Don't assume something is a right angle unless you know for sure. The next type of angle is an obtuse angle. It's an angle that measures more than 90 degrees, but less than 180 degrees. And that's one that's open past the L. and it goes as far as it can, but not to be a flat line. So it goes like this. And that, for example, any angle that's more than 90 degrees, say this could be 125 degrees, for example. That's more than 90 degrees but less than 180, it opens past the L. And the last one is a straight angle. It's an angle that measures exactly 180 degrees. Well, what does that look like? Well, it looks like a line, pretty much. A straight angle makes a line. Usually you have a little vertex right here, so this angle is measured. This is one side of the angle, there's the other side of the angle. This is 180 degrees, and it makes a nice straight line, so that's a straight angle. Congruent angles. Congruent angles are two angles that have the same measure. We talked about congruent segments in the last lesson. Well, congruent angles are the same thing. We have angle F is 40 degrees and angle J is 40 degrees. So the measure of angle F is equal to the measure of angle J, which equals 40 degrees. They're both equal to the same thing, so they're equal to each other. Therefore, since the measures are equal, we can say angle F is congruent to angle J. When we named this angle, since these two angles are equal to the same value, they're equal to each other. Notice when I used measure, I used equal, and when I said that they were equal, I said they are congruent, they have the same measure. I use no M, because congruent you do not use the M with. The next vocabulary that we're going to be looking at are perpendicular segments. Now, perpendicular can work with segments, or it could be lines, or it could be rays. They are segments, or lines or rays, that intersect to form right angles. Now, the notation for perpendicular is an upside down T. It looks like this. That means perpendicular. So usually when you have two segments or two lines or two rays that are perpendicular, you will say one segment is perpendicular to the other. So for example, say that I knew that these two segments were perpendicular. Now, I don't see it here, but how would I know it's perpendicular? Well, if there was a little box here in the corner. The little box in the corner, remember, means right angles. Unless you are told they are perpendicular, do not assume. So, if I know right here that these two angles are right angles, if angle APB and BPC are right angles, then I can say these lines are perpendicular. So, I can say that BP is perpendicular to segment or line APC if angle APB and angle BPC are right angles. Now again, don't assume. Unless you are told or know for certain the measure of these two angles, you can't say they're perpendicular. You can't say, oh, that looks perpendicular, it must be. You have to be able to prove it. Now, let's talk about complementary angles. We did a little of this in the last unit. Complementary angles are two angles whose sum, remember sum is the key word there, is 90 degrees. Sum means to add up to, so you have to have two angles to make 90 degrees. A lot of times you may see it like this. They don't have to be adjacent angles, but they can be. So if I have an angle, two angles like this, and then making this a right angle, I can say that this angle, say, is 60, and this angle is 30. These two angles together add up to 90 degrees, so they would be complementary. The other one is supplementary. It's two angles whose sum is 180 degrees. They have to add up to 180 degrees. It doesn't mean that each one is 90 degrees. So the easiest way to do that is to draw a straight angle and split it. So here's my straight angle. Now this angle on this side, the obtuse angle could be, say, 110. And then the acute angle on this side could be 70. And when I add them together, they equal 180 degrees, so they would be supplementary. So you have to know the difference between complementary and supplementary. And remember, you have to have two angles to do that. The next thing we're going to talk about are adjacent angles. Adjacent basically means next to. The definition of adjacent angles are two angles that share a common ray but have no interior points in common. So if I look at my angles here, I have different angles, AOB, BOC, AOB, AOC, all different angles here. A pair of adjacent angles would have a common ray but have no interior points in common. Well, look at the angles that are next to each other. If I look at angle AOB, what angle is right next to that has a side the same? Well, it would be angle BOC, this angle over here. So angle AOB and angle BOC are adjacent angles. What would be their common ray? Well, their common ray would be the ray OB because both of them have OB in it. One side of the angle is ray OB. So those are adjacent angles. Now, let's talk about angle bisectors. We talked about segment bisectors in the last lesson. And an angle bisector basically does the same thing for an angle that it does for a segment bisector would do. It is a ray that divides an angle into two congruent, that's the key word, angles. If you cut an angle, you get two angles. If you cut a segment, you get two segments. So, if OP, this ray right here, bisects angle AOB right here, then what two congruent angles are formed? Well, if we see it here, here is the big angle AOB. It splits OP here into two smaller angles, this one here and this one here. The name of this angle on top is angle AOP. And that will be congruent or equal in measure to angle POB, or BOP, however you want to say it. Now, you can also use the converse of this. If we know that angle AOP is congruent to angle POB, if we know that this angle and this angle are congruent, then we can say, oh, angle AOB must have been bisected by OP to make those two congruent angles. So bisectors work both ways. If you have a bisector, the angles are congruent. And if you have two congruent angles, then the angle must have been bisected. And since that is true, by postulate we have, every angle has exactly one bisector. You can only bisect an angle in one place. So it's very important to remember, if you're bisecting an angle, you will get two angles. It's not two segments, it's not two rays. You get two angles. Now let's see if we can apply some of the vocabulary that we've just been talking about to some problems. We are given APC is a line, BP is a ray, APB is 3x plus 20, so APB is 3x plus 20, and CPB, which is this angle right here, is 5 times x minus 2. That's the measure of that angle. And we want to determine if PB is perpendicular to APC. So perpendicular, remember that's the upside down T, means perpendicular. We have to determine if this line is this ray is perpendicular to this line or not. Well, what do we have to know about those two lines in order for them to be perpendicular? Well, by our definition of perpendicular, perpendicular lines have to make right angles. Okay, perpendicular lines have to make right angles. So we have to figure out whether or not APB and PBC or BPC are right angles or not. Well, how are we going to do that? Well, we don't know if they're 90 degrees, so we can't say they are. However, if you put them together, what angle do they make? Well, we know that the measure of APB plus the measure of angle BPC together make what angle? Well, if I go from here over to here, I make the measure of angle APC. What kind of angle is APC? Well, APC is a straight angle. So I know that APC will measure 180 degrees. And all I have to do is plug in the rest of the values. 3x plus 20 is APB, and CPB is 5 times x minus 2, and I have my equation. So here's what you're going to do. Finish this equation and determine whether or not PB is perpendicular to APC. We'll go over that in class tomorrow, and then we'll also go over the other two problems that are left on the note sheet.